All right, let's go through these. So on number 1, I'm looking at my 2 bases. Which one's the smaller base? 3. So I'm going to ask myself now, 3 to what power will give me 9? 2. So I'm going to rewrite 9 as 3 squared. So that's going to take the place of this 9 right here. So 3 to the 7x minus 2, that's kind of messy, is equal to 3 squared raised to the power of 5x. What do I do with these 2 numbers now? What did you say? Yeah, what do I do with those 2 numbers that are both exponents? The exponents don't cancel, my bases will. Yep, multiply the exponents, and you're absolutely right. Those bases, because they're the same now, are going to cancel out. So what I'm solving is 7x minus 2 equals 10x. I'm going to have to swing my work around over here. What do I need to do to that to get x all by itself? Minus 7x on both sides. 10x minus 7x gives me 3x. Divide by negative 2 or by 3? Why by 3? Trying to get the x by itself, so I want to divide by the thing that's next to the x. Nice work. So x is negative 2/3.
Don't do decimals.
Yeah, don't leave that one as decimals. If you do that one in decimal form, it would be negative 0.6 repeating. If it runs off your screen, don't write it as a decimal. Number 2, I'm going to be approaching pretty much the exact same way. I have these 2 bases, these 2 things that have exponents on them. Which one's the smaller base? 5 to what power gives me the other base? Squared again. 5 squared equals 25, so I'm going to replace the 25 with a 5 squared. And then that's still raised to the 2x power is equal to 5 to the x minus 5. What do I do from here?
Multiply 2 by 2x.
Yep, multiply by 2 by 2x, so I get 4x equals x minus 5. My bases cancel out because they are the same now. Once again, bring my work over here because I ran out of room. 4x equals x minus 5. Minus x on both sides. So I get 3x equals negative 5. Divide by 3 on both sides, not negative 5, you're correct. And so I get negative 5/3 over here. This is another one that I would want you to leave in its fraction form, not in decimal form. It's going to run off the screen. Plus, fraction form means less work. After you do your division, you're done. I'm trying to save you guys a little bit of time. Nice work on those first 2. Let's go look at number 3. If $3,000 is invested in an account that compounds continuously, I'm going to stop right there because I know that word is really important. And it tells me information about the formula I need to be using. When you see compounds continuously, what's the formula we're going to use there? Yes. A equals P e to the power of r times t. That continuously means you're going to use the formula that has the e in it. A is some future amount. What does the P represent here? Starting amount. Do we know either one of those numbers? The future amount or the starting amount? Starting amount is 3,000. So I can go ahead and substitute that in. 3,000. I know E is not going anywhere because E is a number. Let's read a little further in the problem. It says, what interest rate is needed for the investment to double in 10 years? What do I do with that sentence? What'd you say? Take the 2 for double and do what with it? What'd you say, Jimmy?
Multiply 3,000.
Multiply the 3,000. I want my investment to double. How much was our original investment? 3,000. Double means to multiply it by 2. So how much do we want to have in the future? 6,000. This is what we're going to use for A. All right, is there anything else that I can use from what they said? 10 goes in the place of what?
T.
T. So what do I put in the place of R?
Nothing.
Nothing. That's what we're looking for. It says right up here, what is the interest rate? So that means I need to find R. All right, so I need to walk through my steps for solving this. Where is the thing I'm looking for? What part of the equation is it? R. How would you describe it? Is it a coefficient? Is it a base? Is it part of the exponent? Part of the exponent. So the first thing I need to do is isolate the base that R is an exponent on. So R is a power on what?
E.
E. Here's my base. This is what I want to isolate. I can't touch any of those powers. I don't want to mess with the base, so what can I do?
You'll have to divide 3,000.
Yes, we're going to divide both sides by 3,000. What's 6,000 divided by 3,000? What'd you say? 2. We said we wanted our money to double. When you get to this step in the solving, whatever you said you wanted your money to do, that number should show up when you're done dividing. If for whatever reason we wanted our money to be cut in half, I would see a 1/2 show up right here. So 2 equals E to the, instead of writing R times 10, I'm going to write that as 10R. It's the same meaning. Is it okay for me to switch things around like that when we're multiplying? If I do 4 times 7, is that the same as 7 times 4? So if I switch the order in multiplying, that's okay. Okay, so I've isolated my base. I'm going to have to bring my work over here because I ran out of room yet again. 2 equals E to the 10R. We've got a couple options at this point. We can use our triangle from here, like we learned how to do with Ms. Yeager. Or we can do that thing where we take a log of both sides. That will also work here. Do you guys have a preference? Both lead to the same final answer. I see triangle. All right, so I'm going to draw a triangle. What is our base? E. What's the exponent?
10R.
10R. So that means the argument is what?
2.
2. I'm going to make a log out of this because logs find exponents. So I knew from the beginning that we were going to have to, at some point, use a log.
And you can make that a natural log, yeah?
Yes. Log base E, the argument is 2, equals my exponent of 10R, and you're absolutely correct, Jimmy. Log base E is the natural log. What do I need to do yet to get the R all by itself? Divide by 10 on both sides. And then here's where I would need to grab my calculator. One of my yellow calculators, your own calculator, you can do it in Desmos. What do you have to remember to do, though? ln. When you push ln, it automatically opens up parentheses. What are you going to do? Put the 2 in there, and then what do you have to do, or else it'll give you the wrong answer? Close those parentheses before you hit the division key. ln of 2, close your parentheses, then divide it by 10. Beautiful. What would that be as a percent? Do you remember how when they give us percents, we always do something with it before we use it for R? Divide by 100. Here I'm going the other way, so I would want to multiply it by 100. There you go, 6.93%. If you have a problem on the test tomorrow where it asks you to find the rate and you leave it written out as a long decimal, that's okay. But I did want to connect that back to what we've done before, because most of the time, if you go shopping for investments, if you go into a bank, or you talk with a person that deals with money and investments, they're never going to say the rate is 0.069. They're going to tell you the percentage. All right, we've got one last problem on the bell word. It says solve the equation. What do they mean by solve? What are we looking for? What do I want to find when it says solve? I want to find x. I'm looking for what value would go in here for x. What kind of equation am I looking at? What are the first 3 letters you see? Log. It's a log equation. How many logs are there?
2.
2. If I'm wanting to solve a log equation, I need how many logs only? 1. How am I going to take it from 2 logs to 1 log?
Compact.
Yes. We are going to condense these 2 together. So I know it's going to be written as just a single log. How do I get it down to a single log? What's my argument going to be if it's just 1 log? I'm sorry, what did you say?
How many arguments?
I need 1 argument since I only have 1 log. I want to know what that argument is going to be. What's the argument of our first log? X. So that's going to have to be part of the argument for my condensed log. What do you see after this argument? Before the next log, but after the argument. Addition. When we condense, addition condenses down to what operation? Multiplication. What is my other argument?
X plus 3.
X plus 3. And then that's going to be equal to what? 1. I'm going to need to distribute here since they told me to multiply these. If you want to do that and just write it down as a single argument, that's fine. I usually like to write down what I'm doing first. Do I have it down to just 1 log? Cool. I'm going to pull out that triangle then. What is the base on this log? 10. What's the argument on this log? X squared plus 3x, which means the exponent is what? What do I put up here? 1. So I'm going to rewrite this as an exponential problem. I have 10 to the first power is equal to x squared plus 3x. What is 10 to the first power? Just 10. So 10 equals x squared plus 3x. What type of equation am I looking at? Quadratic. How did you know by looking at it that it was quadratic? What did you see? The x squared. Whenever you see an x squared, it's a quadratic equation. And what do I need these equations to be equal to if I'm going to solve a quadratic? 0. So let's subtract 10 from both sides. It's not going to combine with anything else because it doesn't have an x with it. 0 equals x squared plus 3x minus 10. I'm going to pull out my x. I multiply a and c together, and I get what? Negative 10. Down on the bottom, I put my b term. What's our b term? Yep, 3. What multiplies to negative 10 but adds to 3?
Negative 2, 5.
Negative 2 and 5. Can I use my shortcut on this, or do I have to draw the box, the area model?
You can use your shortcut.
I can use my shortcut. Why can I use the shortcut? A value is 1. In front of the x squared, it's just a 1. Whenever that's the case, I can get away with the shortcut. 0 equals, since I found 2 different numbers, I'm going to have 2 different factors. They both have to start with x. And then I use the 2 numbers that I found. Negative 2, so minus 2. Positive 5, so plus 5. And what do I do with each of those factors now that I've found them? Set them equal to 0. So I'm going to have x minus 2 equals 0. X plus 5 equals 0. So what are my 2 answers for x? Negative 5 and positive 2. Am I done?
No.
No, I'm really close to done. I desperately want to be done. What do I need to do now? Check to see if they're valid or extraneous. So what am I looking for? Yes, I'm going to put it in the place of x, and the argument has to be a positive number. So if I take 2, this first answer that we found, and I put it in here for x, is my argument positive? Yeah, because 2 is positive, right? If I take that 2 and I put it in here for x, will this argument be a positive number? Yeah, because 2 plus 3 is what? 2 plus 3 is 5. So when I take 2 and I substitute it in, it works for both of them. This one is valid. What about if I do the same thing with negative 5? If I put it in here, is that argument positive? No. So what does that mean about negative 5?
Extraneous.
Extraneous. Throw it out. Beautiful. You guys have the remainder of the class time today to work on your review. Guys, FYI, I picked out these problems for the bell work the day before your test on purpose.
Your questions are that something.
I mean, I wouldn't look for these numbers, but I would look for these concepts. Absolutely. You guys can work on any later missing work. The test review, you will be turning in to me tomorrow. So please make sure you work on that. Use your test review, use the bell work, use any later missing work to help inform what you want to put on your cheat sheet for tomorrow. I will be stapling your cheat sheet to your test tomorrow, so you'll be turning it in. Even if you don't write anything on it, you'll still turn in the blank paper. Just that way I know that I didn't lose or misplace anybody's cheat sheets, and you know you didn't lose or misplace it. That way if you want to come in and do corrections or retake on it, we've got everything together in one spot. Last thing I want to show you, I have all the answers for the review posted already. How do I get to this page right here on Canvas? Anybody know? Modules. Go to Modules. You're going to scroll until you see today's date, March 10th. Right here. I'm going to click on the page. That takes me to this. Down at the very, very, very bottom of the page, in green, is where the answers are. Some of these things, like the graphing problem, you're going to need to see my actual answer key to know what that looks like. But for anything that you put into your calculator that you just get a number, I've put those up here so that you guys can go in and check. You're like, I think I did this right. Here's the answer I got. You can get in and look at that. If your answer doesn't match mine, right down here is where all of my work is. So you guys are welcome to get in there and to make use of that. You're welcome to ask me questions, but I want to give you guys the rest of the class period to work.